Good evening, everyone. I am Usman K, Assistant Professor, BITM Ballari. First, I welcome you all to my 10th video lecture on Module 2. So, in the previous video lecture, we discussed about how to create a two-dimensional object. Next, how to fill various types of colors in a created object. Next, we applied various types of operations on a two-dimensional object. So, after learning these two concepts, today I would like to introduce the last concept in this model called two-dimensional weaving. So, in case of two-dimensional weaving, we would like to discuss how we can able to display two-dimensional object on the screen of a monitor. So we already learned how to create an object. Now we need to discuss how to display already created object on the screen of a monitor. So this topic is completely with respect to displaying a two-dimensional object on the screen of the monitor. So we'll see how this two-dimensional weaving concept we need to introduce in this model. So after creating object, next we want to display the created object on the screen of the monitor. So here there are two main concepts are there with respect to this particular model. So whenever we want to create any image in OpenGL, or whenever we want to create any two-dimensional image in computer graphics, we need two concepts. First concept is called modeling. Second concept is called two-dimensional weaving. So as I displayed in this slide clearly, modeling means creating an object. Weaving means displaying the created object on the screen of the monitor. So whenever we want to create a object or any image in computer graphics, first we need to plan how to create any object in computer graphics. That planning is nothing but modeling. The concept is called planning. How to create an object is nothing but modeling in case of computer graphics. So second concept is called two-dimensional weaving. So after creating object, we want to display that object on the screen of the monitor. So instead of telling displaying image on the screen of the monitor, I will tell like this: two-dimensional weaving is nothing but weaving is a process of drawing a view of a model on a two-dimensional display. So as we know that our screen is nothing but two-dimensional display. We want to view the already created object on the screen of the monitor. Then we need two-dimensional weaving concept. So with respect to this slide, I want to combine modeling as well as two-dimensional weaving with respect to one real world example. So assume that whenever a architect want to construct a house or construct a building, first what architect will do means architect first he will plan the uh, how to construct that particular building, means he will prepare blueprint of that particular building. So after preparing blueprint, then he will start constructing that building, or he will start constructing that particular house. So here there are two concepts are there. First, architect will plan. With respect to computer graphics also, when computer graphics engineer want to create any image in computer graphics, first he will perform modeling. So modeling is nothing but creating a blueprint of the image has to be created. So after preparing blueprint or plan of that particular image, then we need to view that image on the screen of the monitor. So as per the architect, so once architect will prepare blueprint, he will start constructing the house. So once he will construct the house, he can view that house on his eyes. So viewing that house on his eyes is nothing but displaying created house on the screen of the monitor. So with respect to architect, he want to view that constructed building in a three-dimensional space. But in case of computer graphics, after creating that particular image by using modeling concept, here a designer here a designer want to view that particular image on the screen of the monitor. So these are the two concepts we are using in this particular topic. One is called modeling, second one is called viewing. So I would like to repeat: modeling is nothing but creating an object, viewing is nothing but displaying created object on the screen of the monitor. So let us begin with first concept is called modeling. So as I said in the previous slide, what is modeling? So I want to explain in detail how we can perform modeling with respect to computer graphics. So whenever we want to perform modeling, so modeling will specify two things. One is it specifies what is the shape of the object you are going to create. Next, what is the dimensions of that particular image. What I would like to say here means, whenever you want to create a two-dimensional object or any two-dimensional image, every image contains two properties. First property is called every image having its own shape in the world. Second property is every image or every object having its own dimensions. So when we are performing modeling in computer graphics, modeling can be specified using a geometric model. Means in computer graphics, we are using a geometric model to specify what is the position of the object in the real world. So what is the position of the object in the real world? Means when you want to create any object, you need to specify mathematical description of that particular object. That mathematical description of the object specifies what is the position of the object you would like to display on the screen of the monitor. Not only displaying the position, the mathematical description of the object, it provides detailed description about that particular object. Means what is the size of the object and what is the shape of that particular object. So these information we need to provide whenever we are creating any two-dimensional object in a computer graphics. So whenever you are providing a mathematical description of the object, every mathematical description of the object having its own units. For example, if you want to specify anything in real world, every object has to be specified with respect to unit. For example, if I want to specify anything with respect to ship, so I need to specify meters for a ship. If I want to specify anything with respect to country, generally I am discussing, I can say that kilometers for a country. See that meters, kilometers, These all are units for the appropriate object. So when you are performing modeling, two things you need to remember. Modeling will give shape of the particular object, and that shape can be defined with respect to mathematical description of that particular object. So next I want to specify one real world example how we can specify shape of the object and how we can specify dimensions for every object in computer graphics. Assume that assume that we want to create one two-dimensional house as I displayed in this slide. So if I want to create two-dimensional house, I can say that this house is nothing but one image. So as I said in the model 1, whenever we are creating any image in OpenGL, we need to divide that image into various types of models I said. So same thing I am repeating here. So whenever you want to create this house, we need to divide this house, or we need to subdivide this house into various types of geometrical primitives. So if you see this house, two-dimensional house, this two-dimensional house is a one image. This image is divided into many number of geometrical primitives, like we have a triangle, like we have a square, like we have a rectangle. Means a combination of triangle and square and rectangle, we created one two-dimensional image and we displayed the two-dimensional image on the screen of the monitor. So this is nothing but performing modeling like this. So when you want to perform modeling here the unit of this house is nothing but in terms of meters. Generally, if I want to specify the size of the house, generally we'll tell that it is a with respect to meters, that is nothing but width into height. You can specify that is nothing but size of the house. So like this house having one shape, like that shape, that every shape having its own geometrical primitives. So here I would like to discuss only what is the meaning of modeling. So here our aim is we want to create one two-dimensional image called house. We divided that two-dimensional house into many number of geometrical primitives, like triangle, like rectangle, like square. So once you divide those object into various types of geometrical primitive, you specify what is the coordinate position of every geometrical primitive in terms of mathematical description of that particular object. So you need to provide what is the mathematical description for the door and what is the mathematical description for the windows. Mathematical description is nothing but we need to provide its vertices. If you provide the vertices of that particular geometrical primitive, it's nothing but you are providing mathematical description of that particular object. If you provide mathematical description of that particular object, that mathematical description it specifies shape of the object, whether it is square or rectangle or triangle or circle or lines or cube or various types of polygons. So you need to remember when you are performing modeling, divide given image into various types of geometrical primitive, and every geometrical primitive having its own units, represent its units in terms of its respective units. Next, if you see this next image or next slide, here we are discussing how to construct image or picture in computer graphics. So I already discussed this topic, but for more clarity, I am discussing how to perform modeling or how to create any image in a computer graphics. So as you can see the heading, I written Roman number 1. There are 3 Roman numbers are there here. I written, whenever you want to construct any image in computer graphics, first we need to give the geometrical description or geometrical specification of the object. This is first requirement in a computer graphics whenever you would like to create an image or whenever you want to construct any image or picture. So as I written clearly, geometrical description will provide, see that here, please you see this slide, geometrical description of the image. It specifies or it determines what is the location of the particular object and what is the shape of that particular object. So these are the two things we can achieve by providing geometrical description of the object. For example, if I want to specify box, assume that this is nothing but one image. If I want to specify one box or if I want to create one box in computer graphics, if I want to display this box on the screen of the monitor, then how to create this box means in 2D I am discussing. Whenever you want to create this box as the image, you need to provide geometrical description of this particular object called box. What is the geometrical description of this box means? Geometrical description of this box indicates what is the position of its corners. So as you can see that in case of two-dimensional, we can view only front end of this particular box. So when you want to view only front end of this particular box, you need to specify 4 corners of this particular box. So position of its corner is nothing but vertices. Means when you are specifying position of the object in a computer graphics, you specify position of the object in terms of its corners. If 4 corners are there, I can say that either it can be rectangle or it can be square. So here you can see that I specified first 2 vertices. After specifying vertices, by seeing vertices only I can say that what is the shape of this particular object. The shape of this particular object, either it can be rectangle or it can be square. Either it can be rectangle or it can be square or it can be cube also. But here we are discussing only two-dimensional. So when we are specifying two-dimensional geometric transformations or two-dimensional weaving, I can say that only we can able to view front end of the given box. So here I would like to highlight position is nothing but we need to specify its vertices. By seeing vertices, I can specify what is the shape of the particular object. This is with respect to box like this. So now in Roman number 1, I said we need to provide geometrical description of the particular object has to be created. So once you specify geometrical description of the object, we need to represent those geometrical description of the object by using Cartesian reference frame. So we learned we have two-dimensional Cartesian reference frame and we have three-dimensional Cartesian reference frame. But here I am discussing only two-dimensional Cartesian reference frame. So in the previous slide or in the Roman number 1, I specified the geometrical description of that particular box. Assume that I specified 4 coordinate positions. Now I need to represent those 4 coordinate positions in a Cartesian reference frame. So as you can see this image here, x and y coordinate represent Cartesian reference frame where origin is 0, 0 and I represented the position of this particular box in a two-dimensional Cartesian reference frame by assuming its own dimensions. Like you can assume width width and height either with respect to meters or with respect to inches. So this considering units, considering that is nothing but dimension with respect to units or inches. This units and this inches and meters is nothing but it is the dimensions of that particular object, or I can say that it is a unit we are assuming and we are creating that box in our real coordinates or by using our own coordinates. By using our own coordinates we specified the size of the object or position of the object in a two-dimensional Cartesian reference frame. This is Roman number 2. So after specifying the given object in a two-dimensional Cartesian reference frame, then we need to use the third concept, that is called constructing a scene or image containing multiple objects. So till now I discussed how to represent only one object in a Cartesian reference frame. Assume that we are creating one image. That image contains multiple objects. Then how we need to perform modeling? When a given scene or when a given image contains multiple objects, then how to perform modeling means we are using three steps here. We are using two steps here. So whenever you want to perform modeling when image contains multiple object, first what we need to do means the step one says that define shapes of individual objects in a separate Cartesian reference frame. What it means, for example, if given image contains four different objects, or as you can see that this house only, if you see this house contains one, two, three, four different objects. First object is called triangle. Second object is called four walls of the house, but I can able to view only front wall of the house. I can say that this is the second object. Third object is called one window. Fourth object is called one door. So when this image contains multiple objects, we need to represent the shape of the every object by taking separate Cartesian reference frame. So in this example, there are four objects are there. Represent each object by using one separate Cartesian reference frame. So this is the first step. This is the first step. So as I written, define shapes of the individual object in a separate reference frame. So after specifying shapes of the or multiple objects in multiple Cartesian reference frame, step 2 says that once the individual object shapes have been specified, then we can construct a model. See that we can construct the model or scene by placing the objects into appropriate location within a scene. Means we need to merge here. We need to merge multiple objects into one object or multiple Cartesian reference frame content into one reference frame, one Cartesian reference frame. That one Cartesian reference frame is called world coordinates here. Means you specify shape of the individual object by taking your own coordinates are real coordinates, represent it in a various Cartesian reference frame. That is step 1. After representing those objects in a separate Cartesian reference frame, next we need to combine all those Cartesian reference content into one Cartesian reference frame, and representing or merging those objects into one single image is called world coordinates. And we have only one Cartesian reference frame here. So let us see the example. If you see the example, you may get the clarity. Assume that I have taken one real world example here. Please you see this slide. Assume that assume that I want to perform modeling to create one bicycle. So we know that this is our childhood example. We know that the what are the parts of the cycle or bicycle. So now if we want to create two-dimensional image called bicycle, we need to represent. I am discussing those steps. I written Roman number 3. I am discussing Roman number 3 here. When you want to when you want to create an image in a two-dimensional reference frame, first we need to divide that bicycle into various types of geometrical primitives or various types of objects. So we will represent each object of the bicycle by taking our own Cartesian reference frame. Assume that if bicycle contains 10 subparts, we need to create 10 subparts individually by taking one separate Cartesian reference frame. So I did that only. So here in the step 1, we represented each subpart of the bicycle by using different Cartesian reference frame. So for example, I represented wheel of a bicycle using one Cartesian reference frame, that is called local Cartesian reference frame, by using local coordinates. Next, I specified the handle of that bicycle by using another Cartesian reference frame. Next, I represented seat of that bicycle using another Cartesian reference frame. Next, I represented that bicycle having chain also. So I represented chain by using one more Cartesian reference frame. So like this, we have pedal also. There are two pedals are there, but I represented only one pedal. I will make use of the same code to create one more pedal. Similarly, there are two wheels I need. I need I need two wheels to create one bicycle, but I will write code only to create only one wheel. By changing the position of that already created wheel, what I will do means just I will change the position. If I change the position of that already created wheel, I will get one more wheel in a different position within the two-dimensional plane, in a two-dimensional plane. So like this, what I did means here. So please you see that I represented each object of the bicycle using different or separate Cartesian reference frame. This is called step 1. Next, I combined all these subparts of the objects in a only one Cartesian reference frame. That Cartesian reference frame is called world coordinate frame. So in the world coordinate frame, I combined, or I can say that I constructed one bicycle. I constructed one bicycle in a such a way that by combining all the subparts of the bicycle. So once you combine all the subparts of the object or image, I can represent those in a single Cartesian reference frame. So this is nothing but step 2. So in computer graphics also, whenever we want to create any object, either two-dimensional object or three-dimensional object, we are using this particular concept only. So this is now what I did means here I discussed only modeling here. So whenever you want to create any two-dimensional object, first we need to perform modeling. So modeling will give two types of information to the programmer. First type of information is what is the shape of the particular object. So as you can see that bicycle contains wheel. The shape of the wheel is nothing but like a circle, like a circle. Next we have a seat is there. That seat is also one shape is there. One type of one shape is there. Chain is also there. That is also one type of one more shape. Means here first we need to define what is the shape of the various object. And what I did means I divided that bicycle image into various types of sub objects, that is called geometrical primitives. Next I specified what is the position of the every sub object in a two-dimensional plane. That representing each object in a two-dimensional plane is nothing but we are specifying what is the dimension or what is the position of that particular object in a two-dimensional plane. So after combining all those sub objects in a one main object, I will get one image or one scene that contains multiple objects. So I represented multiple objects in a multiple Cartesian reference frame by using various types of various positions. Various position wheel having two wheels are there, one wheel at the front and one more wheel at the back side. So like this I specified each part of the object by specifying its own dimensions. Finally I combined, I integrated all the parts of the object, then it will become one complete image that contains multiple objects. This is about how to perform modeling in a computer graphics. So whenever we are creating either two-dimensional image or whenever we are creating three-dimensional image, the first stage is nothing but, our first step is nothing but we need to perform modeling. So modeling will give clear picture or clear plan how to create the object. So once you perform modeling, your plan is ready or your image is ready or your image is created. Either it can be two-dimensional or it can be three-dimensional. But now we are discussing two-dimensional images. So once you completed modeling, it means that your object has been created. After creating object, next we need to view that object on the screen of the monitor. So viewing that object on the screen of the monitor is nothing but displaying already created image on the screen of the monitor. That concept is called two-dimensional viewing. So two-dimensional viewing is nothing but displaying the image on the screen of the monitor. But the definition says that viewing is the process of drawing. Drawing means displaying. Drawing a view of a model on a two-dimensional display. Model means already we created image or already we defined what is our plan to display this image on the screen of the model, on the screen of the monitor. Whatever the image you displayed, whatever the image you created, now you would like to view that image or you would like to display that image on a two-dimensional display. Two-dimensional display is nothing but, it is nothing but our screen. We would like to view this image on the screen of the monitor. Then we need two-dimensional viewing concept. So whenever we are using two-dimensional viewing concept, so as I said in the previous slide, the geometric description of the object or a scene provided by the model, as we already learned. So after providing geometrical description of the object, Now we need to convert that into graphical primitives or set of graphical primitives which are displayed where desired on a 2D display. The meaning is, after providing or after specifying geometrical description of the object, we need to convert geometrical description of the object into a set of grammatical primitives, and this set of grammatical primitives we want to display on the screen of the monitor. So the same abstract model may be viewed in many different ways. Means once the object has been created, you can view that object in different ends. For example, you can view that object from the far away or near or looking down or looking up. Means that object you would like to view in a different ends of that particular object. So this is nothing but two-dimensional view or two-dimensional viewing. So when we want to use two-dimensional viewing, we need to use real world coordinates. The real world coordinates is nothing but it is a logical to use dimensions which are appropriate to the object. Means we need to specify what is the unit of that particular object. So as I specified three examples, you can go through the three examples. Whenever you are creating any two-dimensional object or three-dimensional object in two-dimensional viewing, you need to specify your own coordinates. Those own coordinates is called real world coordinates. Real world coordinates. So when you created object, after creating object, next when you want to view that object, so you can view that object in a various size by zooming in and zoom out without actually having to change the model. So what we are discussing in this particular slide means, once the object has been modeled or when the model is ready, you can view that object with various size without changing its position. It is how it is possible means, you know that we are using synthetic camera here. When we are using synthetic camera, we know that when we move the camera near to the object, we know that the size of the object is goes on increases. That is called zooming in. Zooming in. When you move the camera, synthetic camera, away from the object, the size of the object will goes on decreases. This is nothing but zoom out. Means with respect to object, either you can view that object on the screen by increasing the size of the object or decreasing the size of the object. So this increasing and decreasing the size of the object is nothing but it's a one type of viewing only, right? So if you are increasing the size of the object, we are performing zooming in. When you are decreasing the size of the object, it means that you are performing zooming out. So actually this is real camera concepts. But I said in the module 1, here we are using synthetic camera. The properties of the synthetic camera, it is similar to the properties of the real camera. Real camera. So those concepts we are using here. Those we are using here. So now what we need to do means here, in case of two-dimensional viewing, we need to decide how much of the model should be drawn. This is the first thing you need to decide. Means once the model has been ready means once the object has been created, in that created object, how much of that particular object you decided to display on the screen of the monitor. Whether you want to display the complete object on the screen of the monitor or part of the object on the screen of the monitor like this. Once the object has been created, next we need to specify two things here. Means we need two basic properties whenever we want to display the already created object on the screen of the monitor. So these are the two things we need. First, how much of the model should be drawn? Means in that object, whether you want to display the complete object on the screen of the monitor or part of the object you want to display on the screen of the monitor. So first you need to decide. This is the one thing. Second, you need to decide where should it appear on the display. So we have a screen. The size of the screen, we know that its size is x minimum to x maximum with respect to x axis, and y minimum to y maximum with respect to y axis. So within this area, where you would like to view this object on the screen of the monitor. So these are the two basic properties we need whenever we are displaying created object on the screen of the monitor. So assume that you created one house. Whether you want to display whether you want to view or whether you want to display the entire house on the screen of the monitor or part of the house on this monitor. This is the one thing you need to specify. Second, in that display area or on the screen of the monitor where you would like to display this particular house. So these are the two things you need to decide whenever you are performing two-dimensional viewing. So when we are performing two-dimensional viewing, we will use two types of rectangles here. So first type of rectangle is called window, or it is also called clipping window. Second one is called viewport window. So these are the two types of windows we are using in two-dimensional viewing. Just I would like to go back to previous slide, and I want to add one more concept here. I would like to explain one more concept. So whenever you want to display any image on the screen of the monitor, here we need to learn how do we convert real world coordinates into screen coordinates. Means whatever the object you created, if you want to display this image on the screen of the monitor, you need to perform mapping here. So in the next slide I will discuss how we can perform mapping. So as you can see that here, I already said we are using two types of windows. One is called window or clipping window. Second one is called viewport. So whenever you want to display any object on the screen of the monitor, here please you see the screen. I have a one scene or I have one image. In this image multiple objects are created. So this is nothing but one complete model. So in this image you need to decide first one thing, whether you want to display the complete scene on this screen of the monitor or part of the screen on the screen of the monitor. Now I decided, please you see the window. I have one yellow color window here. Please you see this yellow color window. I decided in this house or in this scene we have a multiple objects, like we have a chairs, we have a table, we have a various types of walls, we have a roof. These all are the multiple objects are there. Even we have a desktop also. Now in this multiple objects, we decided we want to view only few objects in this particular scene. So how to specify which are the objects actually you want to display on the screen of the monitor, means that is called clipping window. So here yellow color, please you see the left diagram, the yellow color one window I displayed. This yellow color window represent, this is the clipping window. So the clipping window, it decides what is to be viewed. So that is nothing but clipping window. Now next we need to create viewport. So viewport specifies where is to be displayed. So I will repeat, window specified what is to be viewed, viewport specifies where is to be displayed on the screen of the monitor. So as you can see that I displayed one image. Assume that this is right side I am telling, we have a viewport. I written clearly this is a viewport. So this is the second type of window. Then what I need to do means here, I need to specify two windows. Please you see the second image. First window is called clipping window. Second window is called viewport. So whatever the object you want to display on the screen, or whichever the object you want to view on the screen of the monitor, you need to specify by using two windows. One is called clipping window, that is left side is there. One more is called viewport. Then I need to map window clipping window coordinates to viewport coordinates. When I map clipping window coordinates to viewport coordinate, then only I can able to display whichever the object I created, whichever the object I created and whichever the object that lies inside the clipping window, I can able to view this object on the screen of the monitor with respect to viewport. So if any part of the object that lies in the clipping window, it has to be lies inside the viewport. Then only we can able to view this particular object on the screen of the monitor. So the next topic is, if I want to map clipping window coordinates to viewport coordinates, we need to perform series of transformations. The topic name is called two-dimensional viewing pipeline. Two-dimensional viewing pipeline. So the main aim of the two-dimensional viewing pipeline is, we want to map our clipping window coordinates to screen coordinates, or whichever the object you created. If you want to display this object on the screen of the monitor, you need to map object coordinates to the screen coordinates. The topic name is called two-dimensional viewing pipeline. So if you want to perform series of transformations, means if you want to map object coordinates to screen coordinates, we need to perform series of transformations. But to perform this series of transformations, we need two basic things. So as I discussed in the previous slide, now also I am discussing same thing. So whenever you want to perform series of transformations, we need two types of window. One is called clipping window, one more is called viewport. So clipping window is nothing but, it is a two-dimensional rectangular area selected for displaying image. As we already discussed this, which part of the object you would like to display, we need to select that part of the object within the rectangular clipping window. So I can say that clipping window is nothing but, it is a two-dimensional rectangular area selected for displaying image. It can be any shape and size and orientation, but generally in our OpenGL program, with respect to two dimensional, I can say that our clipping window, either it can be square or it looks like a rectangle. So as you can see that second type of window is called viewport. So this is another concept we need whenever we want to view the object on the screen of the monitor. So viewport is a part of the clipping window only. Or viewport, it defines, as please you see that I written clearly what clipping window specifies means, clipping window it specifies or it defines what we want to see on the output device. I will repeat, clipping window it defines what we want to see on the output device, but viewport defines where the object is to be viewed on the output device. So these are the two definitions you need to remember. What we want to see, that is nothing but clipping window. Where we want to see on the display device, that is nothing but viewport. So I drawn one diagram also. Please you can see that first we have a display screen, means that is nothing but monitor screen. Next we have a size, we specified size of the clipping window. We need to map clipping window coordinate with the viewport coordinate. Then only we can able to view the object on the screen of the monitor inside the viewport. So these all are the two concepts we need whenever we want to perform series of transformations. So as you can see this one more example, assume that I created one object. Assume that I created one object that is nothing but one polygon. Please you see the left side diagram, right? Left side diagram. I created one polygon. I created one polygon. In this polygon, I will specify which part of the object I would like to display on the screen of the monitor. Means what you want to view or what you want to display on the screen of the monitor. So as I decided in this particular polygon, I decided I would like to see center position of this polygon. So I specified one square, one rectangle here, clipping window. So whichever the part of the polygon that lies inside the clipping window, only this part of the polygon I can able to view on this screen of the monitor with the help of one more window called viewport. Means, see, please you see that whatever the part of the object or whatever the part of the polygon that lies inside the clipping window, only that part of the object is lies inside the viewport. Means whichever the part of the object that lies inside the clipping window, only that part of the object has to be displayed on the screen of the monitor. So how to display means I need one more concept called viewport window. So viewport window decides where programmer want to view this particular object on the screen of the monitor. So whenever we want to view any object on the screen of the monitor, we need to perform here series of transformations. After performing series of transformations, I can say that I can view whichever the part of the object that lies inside the clipping window, only that part of the object I can able to view on the screen of the monitor. Then I can say that here I need to map clipping window or object coordinates to the viewport coordinates. Then I need, these are the various types of transformations. So this is called two-dimensional viewing pipeline. So this is the entire concept. So I am explaining entire concepts how we can create and display a two-dimensional image or three-dimensional image on the screen of the computer. Or here I am combining two concepts. First concept is called how to create any two-dimensional or three-dimensional object in computer graphics. Next, how to display already created object on this screen of the monitor. So I am concluding like this. I am concluding whatever the topics I discussed today. I would like to conclude those topics with respect to series of transformations. So assume that here we want to create one image in computer graphics, or we want to create one image in OpenGL. So whenever we want to create any image in OpenGL, first we need to perform modeling. If you want to perform modeling, you need to specify modeling coordinates. So as you can see that in the bracket I written clearly how to represent modeling coordinates. So I represented modeling coordinate like x subscript MC, means modeling coordinate with respect to x axis. Next I specified modeling coordinate with respect to y-axis. Next I specified modeling coordinate with respect to z-axis. Means first we need to specify modeling coordinates of the image that contains multiple objects. And I clearly written what is the meaning of modeling coordinates or modeling. Modeling is nothing but here I written clearly representing position of the object using multiple reference frame. Means we are assuming our image contains multiple objects. Our image contains multiple objects. We need to specify the position of the object with respect to modeling coordinates. So as I said that we need to represent every object position with respect to Cartesian reference frame. But here I am explaining with respect to three-dimensional. As I written with respect to three-dimensional, but we need to discuss with respect to two-dimensional only. So here first we need first type of transformation, that is called modeling transformation. This is the first type of transformations we are using whenever we want to create and display the image on the screen of the monitor. So what is the use of modeling transformation means? Modeling transformation will convert modeling coordinate to world coordinates. So as you can see that modeling coordinates are represented using x subscript modeling coordinate, y subscript modeling coordinate, z subscript modeling coordinate. When you perform modeling transformation will convert modeling coordinates to window world coordinate. So here we are using series of transformations, like we converted modeling coordinates to world coordinate. So in case of modeling coordinate, we have multiple objects, but when you converted modeling coordinate to world coordinate, so we integrated multiple objects from multiple Cartesian reference frame into one Cartesian reference frame, that is called world coordinates. So after converting modeling coordinate to world coordinate, so here I written clearly what is the meaning of world coordinate, right? So next we need to perform second type of transformations, that is called convert world coordinate to weaving coordinate by using weaving transformations. So you can see that in case of world coordinate, we are representing world coordinate with respect to x world coordinate, y world coordinate and z world coordinate. When you apply weaving transformations, it will convert world coordinate to weaving coordinate. So when you convert world coordinate to weaving coordinate, actually rasterization process will take place. So as we discussed, what is rasterization, how computer graphics will convert each pixel information into corresponding image on the screen of the monitor. So I will repeat, when you are performing weaving transformation, that is converting from world coordinate to weaving coordinate, rasterization process will take place. And here in case of weaving coordinate, we will define position and orientation of the hypothetical camera. Means here we are defining our clipping window, means which part of the object you decided to view on the screen of the monitor. So weaving coordinates is nothing but we are specifying size and shape of the clipping window. So whenever you specify the clipping window, whichever the part of the object that lies inside the clipping window, only those part of the object is mapped to screen coordinate. But for the time being, weaving coordinates you assume x subscript VC represent weaving coordinate with respect to x-axis, with respect to y-axis, with respect to z-axis. Next, we need one more type of transformation called projection transformation. So we want to map or we want to translate weaving coordinates to projection coordinates with the help of projection transformation. But to translate, when we need projection transformation means whenever we want to perform three-dimensional viewing, then only we need projection transformation. But here we are performing two-dimensional viewing. So in case of two-dimensional viewing, we don't want projection transformations. But you assume it is a three-dimensional viewing. If it is a three-dimensional viewing, then we need to map viewing transformation, viewing coordinate to projection coordinates with the help of projection transformations. As you can see that projection transformation defines where we want to see our image or where you want to project our image on the screen of the monitor. So here when we are using 2D, we don't want to discuss projection coordinates. So directly we want to discuss normalization coordinates. So as what we did, we assume that we converted viewing coordinates to projection coordinates with the help of projection transformations. Next, we need to convert projection coordinates. See that projection coordinate is represented x subscript pc. P represent projection coordinate. Now, we need to convert projection coordinate to normalization coordinates by using normalization transformations. So when you map projection coordinate to normalization coordinate, then your image will become independent of the display device. Means assume that you created one image to display that image in a laptop. When you normalized that image, then that normalized image can be displayed either in a laptop or in a desktop or in a mobile screen. Means that image will become coordinate independent. So when image becomes coordinate independent, then you can display that image in any type of display devices. So that is the use of normalization transformations. Generally, normalization transformation we are we are representing with the range of 0 to 1 or minus 1 to 1. Please you see this slide. You can represent normalization coordinates either with respect to 0 to 1 or minus 1 to 1. You will get one rectangle. You will get one rectangle or you will get one square. You are representing that image within the normalization coordinates. So what we did, we converted projection coordinates to normalization coordinates. As you can see, the subscript x n represent normalization coordinate with respect to x axis. After converting projection coordinate to normalization coordinates, the last step is we need to convert or we need to map normalization coordinates to device or screen coordinates. Device or screen coordinates with the help of viewport transformations. Viewport transformations. So what this viewport transformation will do means it map normalization coordinate to device or screen coordinates. So these are the sequence of transformations we performed whenever we want to display any created image on the screen of the monitor. So I will repeat. Assume that we have one two-dimensional image. Whenever we want to create and display two-dimensional image or three-dimensional image on the screen of the monitor, we need to perform series of transformations. Like we need to perform modeling transformation, viewing transformation, projection transformations, normalization transformations, viewport transformations. So if you perform this series of transformations, then only the created object is displayed on the screen of the monitor. So today we discussed only one concept that is called what is two-dimensional viewing. So I would like to conclude this session here only, but before concluding this topic, just I would like to summarize what are the concepts today we discussed. So first, I said whenever we want to create any image in computer graphics, either it can be two-dimensional image or it can be three-dimensional image, we need two things. We need modeling and we need viewing. Modeling defines how to create the image. After creating image means after performing modeling, next we need to perform two-dimensional viewing. Two-dimensional viewing defines how to display already created image on the screen of the monitor. So with respect to two-dimensional viewing, when you want to display created image on the screen of the monitor, you need to perform 5 sequence of transformations such as modeling transformation, viewing transformation, projection transformation, normalization transformation, viewport transformations. So after performing this series of transformation, that image is displayed in the form of pixels on the screen of the monitor with in a specified position on the screen of the monitor. And to perform this, we are using two types of windows. We are using clipping window that defines what you need to display on the screen of the monitor, or which part of the object you decided to display on the screen of the monitor. Next type of window called viewport window. Viewport window defines where you want to display that created object that lies inside the clipping window on the screen of the monitor. So these are the two things or two basic things we need whenever we are performing two-dimensional viewing. Thank you.